3.2, number 55. Use the definition of derivative to find the derivative of f of x. So limit as h approaches 0 of f of x plus h minus f of x over h for the function which is 2 minus 3x. All right, so just follow the definition, plug the function in to this formula, and you should be able to algebraically compute the limit here. So let's see, f prime of x will be limit of this difference quotient. I need to plug in x plus h in here for x. So we'll have 2 minus 3 times x plus h. There's the substitution of x plus h into the function for the left part of the numerator, and then subtract off, that's that subtract there, f of x, the original function itself, unchanged, 2 minus 3x. The bottom stays the same. Now, since the definition of derivative is inherently a 0-0 indeterminate form, right? As h gets close to 0, this will get close to f of x minus f of x, which is getting close to 0, and of course h at the bottom is heading towards 0. So we anticipate that there should be some way to remove this factor of h in the bottom so that we can actually take the limit and it's no longer 0-0. It happens almost every time when you do these problems. So we anticipate a factor of h to appear above to cancel. So that will happen. 2 minus 2 is 0. Negative 3x plus 3x is 0. And then we just get negative 3h. So there's our factor of h we were looking for. That was kind of our algebraic goal. So negative 3h over h is cancel, and now I have the limit of a constant. But the limit of a constant is, of course, itself, regardless of what variable is approaching anything, it doesn't really matter. So this is negative 3. So there is our answer, and it makes perfect sense with the function that was selected because this is a linear function, and we know that linear functions, lines, have constant slopes, and we know that the slope of a linear function is the coefficient on x when written in slope-intercept form. So therefore, the fact that this was 2 minus 3x means negative 3 had to be the derivative value, and the derivative produced exactly what we expected, produced a slope of negative 3 for every value of x for this function. So f prime of x is negative 3 always.